Hey, what's up? Welcome back to TritonTv. Okay, this episode is going to be maybe a 10 or 15 minute episode. I'm going to try to keep it under that time. So, I am doing some stress tests on my computer right now. I am trying to dial in my 5.0 gigahertz overclock on my i7-7700K. And I just wanted to show this real quick. I've been running a stress test. It is May 15th. 5:56 or so, yeah. And I started the test at 4:35, and I'll show you what it is. So I am running this. Let's just explain the screens here. This is just the task manager, just to keep an eye on how much RAM and CPU usage I'm at. You can see we're at 4.8 gigahertz CPU clock speed, and we're running about 95% of our RAM capacity as indicated by this chart. So what's going on right now is we have the i7-7700K clocked at 4.8 gigahertz for AVX instruction sets. And basically what AVX instruction sets are, this is CPU Z. It's a really good program that monitors voltages. You can see here the core voltage. I'll explain that here in a bit in a lot more detail. That's the voltage that the CPU is being supplied right now. And this is the multiplier that in my last video of rebuilding the PC, I talked about the bus speed, which is right here. That's the clock rate of the motherboard. CPU multiplies it by that, and then you end up with the CPU clock rate. So I have the voltages set at 1.352. We have a little bit of what's called a V-drop or V-droop, however you want to say it. The voltages drop down slightly a bit under load, and I am running this program here called Prime 95. This is a program that I believe does some type of intense calculations involving integration and finding prime numbers very, very large. So you can see here, I started this program just to show you the computer time here. We have, like I said, almost 6 p.m. on the 5/15/2021, and this was started at 4:35. This is the longest stress test so far that I've ran on this CPU at this clock rate. But you can see here, each one of these quote-unquote workers is running a test on one of the logical processors. And what that means is, so if you look over here, we have 4 cores, because this is an i7-7700K. We have 4 cores, and each core is capable of running a hyper-threaded processor, which basically gives you another core. So essentially we're running 8 cores of processing right now at maximum capacity, and we've been doing that for well over an hour, as well as the RAM. So these algorithms here that are running on this screen are running these calculations over and over and over and over and over and over and over again, probably thousands of times, if not tens or hundreds of thousands of times per second. And after about 6 minutes or so, it will double check the end result to known quantities to see if the CPU and the RAM and everything is passing the information back and forth and not rounding numbers more than it should. So I just wanted to show this real quick while this is running before anything crashes and whatnot. But it's pretty stable. To be able to pass the Prime 95 blend test, let's see if we can open that. Let's see here. So you can see here, this is when you click on, I'll do that again. When you click on options and go to torture test, this menu pops up, and you can run different algorithms to test your system out. Right now I'm running a custom blend. I just leave the blend FFT numbers, which stands for Fast Fourier Transform, which are some type of crazy algorithms that transform waveform functions into 3D space and the opposite. I don't know, it's really complicated math. I'm not going to get into that, but it runs these algorithms, and you can set the FFT size. I just leave it on the blend, but I go to custom, so I can come down here and enter a number in for the RAM usage. So this specific blend test, like I said, maxes out the RAM to what you set it at. So right now we're running 15.1 gigs of RAM, 100% CPU usage, and it's running these calculations over and over and over again, and then it changes the number that it's looking at and runs different calculations. Each one of these workers will fall behind other ones based off of how much usage Windows and the monitoring software and whatever else you have running at the time. Those will steal some CPU cycles, hence why some of these workers are at slightly different tests. So let's lift this up. So hopefully that makes a little bit of sense right now. Basically, when you're overclocking, you need to stress test your system in order to understand if you can fully utilize that clock rate, and if you have any underlying issues with voltages. For example, right before I got this clock rate as stable as it is now, I would have blue screens of death, where within a minute of running some of these algorithms, the CPU just doesn't have enough juice for the temperature that it reaches and the clock rate that it's at in order to fully supply the CPU with enough juice to run the calculation all the way through whatever parts of the CPU that it's using. It's pretty complicated stuff, actually, when you think about it. So basically, we have a couple of components. You have the voltage, the V core, or the core for the voltage for the cores, which you have the clocked cores, or you have the uncore, which is all the other functions outside of the normal functions. I should put a picture of a CPU right here, especially this CPU. So there's multiple different clock rates that you mess with. Typically, from what I've read in the guides, you don't mess with the uncore until you have a pretty much stable core clock rate. And the core clock rate is this clock rate right here. It's the actual part of the CPU that runs most of your computations, and then the uncore is all of the other functions of the CPU. So yeah, so you have your base clock rate, your voltage, and so here's what I've learned. We're going to dive into these settings here in a bit. Once I'm done with this test, I think I'm going to let it run for another 2 hours. I'm going to try to hit 4 hours, which is the longest I've let these tests run on the CPU. I wanted to make sure I could pass 30 minutes on every single little test. I'll explain that a little bit later. There's the small FFTs, there's the blend test, but there's the AVX and non-AVX instruction sets. So when you're overclocking, you need to understand what AVX and AVX2 instruction sets are going to do. My understanding of AVX and AVX2 instruction sets is they are better utilize logical processes inside the CPU to fully utilize some certain algorithms and certain computations. They run hotter, but they get certain calculations done faster. So you want your CPU to have enough power to run these hotter computations, but you need to understand that your CPU is going to get hotter. And when I say your CPU, I mean each individual core. And like I said, in the i7-7700K, you have 4 cores that each utilize hyperthreading, so you end up with 4 times 2, you end up with 8 logical processors, 4 of which are physical. Pretty complicated stuff. There's a lot of electrical engineering, physics involved. There's a lot of actual physical hardware, just technicalities involved. So here in a little bit, we're going to dive into the BIOS and I'm going to explain some of these settings. But basically, you have essentially 4 tests that you're going to run with this program, Prime 95. There's other ones like Ada 64, Realbench. I chose Prime 95 just because some of the guides that I've read use this program in particular. So, and from what I hear, the small FFT tests on Prime 95 are some of the most grueling tests you could possibly run on your CPU. The small FFTs, fast Fourier transform algorithms, test your level 1, level 2, and level 3 cache inside of the CPU. If you're unfamiliar with what those are literally the fastest type of memory on any computer component in the entire world, and they're extremely expensive. That is why, let's see if we can find this here. Yes, right here. That is why the L1 cache, let's see. So the L1 cache is only 32 kilobytes. The L1 instruction set, I'm not exactly sure what that is, but that's 32 kilobytes. The level 2 is 256 kilobytes, and the level 3 is 8 megabytes. The level 1 is the fastest one by far, but it's very limited. So basically what the CPU does is it has those 3 levels of cache, and it basically passes information in between the two and then sends it out to RAM, and then when it needs certain instruction sets and certain data, it calls it back from the RAM, processes it in the cache, and then sends it back out. Really complicated stuff. If you haven't taken a computer science class, it's probably going to sound like a bunch of mambo pajambo to you, but just know that there's multiple layers of where the processes are happening at. And your CPU is constantly passing information in and out of RAM in order to fulfill the processing inside the cache. When it's done with that data, it makes a mark, a memory address, to RAM, and the bus, the highway of wires underneath the CPU and the DIMM slots, is where it sends that data. Actually, that's why this gap right here between the CPU and the RAM is small, because electrical engineers figured out that in order to utilize the fastest possible speed of light transmission of the data, you actually have to limit the distance between the CPU and the RAM. It's like crazy mind-blowing physics. We're literally talking about microseconds here, and that distance matters because, like I said, you're passing information from the CPU cache to the RAM and back and forth. Basically, the CPU wants to always utilize the cache for the fastest processing possible, but it doesn't have that much memory storage in those cache, and that's why it passes it in and out of the RAM. Back in the day, you had a thing called thrashing, which is very rare nowadays. When you run out of RAM, what would happen is your CPU would then say, okay, I've used all of my memory address allocations in the RAM. Now I need to use the hard drive as RAM. So basically what it would do is it would send all the data it could to the RAM. When you ran out of RAM space, which, like I said, was way more common back in the day, not nowadays, it would literally physically write the RAM data to the hard drive, and you would hear the physical reading and writing of the disk as this like stuttering noise, and it's called thrashing. It's insane. You don't really have that happen nowadays, and even if you did, the solid state drives that most computers have would do that a lot faster, and you wouldn't actually hear it. Crazy stuff. We're going to dive into the BIOS here in a couple of hours. Stay tuned. Mind-blowing stuff, I know. All right, so we just hit 8:40 p.m. I started this at 4:35. I'm going to hit test, stop. Over here, click OK. We just stopped all workers. Let's show the temperatures dropping in all the cores. There we go. The clock rate has jumped back up to, whoa, there we go, 5 gigahertz. Voltages are at 1.36. Okay, so I just want to explain a little bit what happened here. So if you look at worker number 1, 113 tests in 4 hours and 4 minutes, 0 hours, 0 warning. That's good. Worker number 2, 104 tests in 4 hours and 4 minutes, 0 hours, 0 warning. That's good. 118 tests, 4 hours, 118 tests, 117, 121, 128, and 128. So we passed all the tests, which is really good. And that's 4 hours running the AVX blend test, which means that my CPU gets downclocked to 4.8 gigahertz, which I honestly think I can raise that up to 4.9. There's a setting. I'm about to shut off the computer and go into the BIOS and explain some of the voltages and everything that I've learned about overclocking this CPU. So I'm just going to show you my notes here real quick as I update these. So I just keep a little notepad for, oh man, what is up with, I don't know why, but it did it again. I'm gonna stop it and restart it. Okay, I don't know why this camera does that. It's been doing it a lot lately. So here we go. The only thing that's gonna change now is the actual V-Core blend AVX offset. So I'm gonna look over here at the temperature. Max temperature for the CPU package was 92 degrees. So I'm gonna go ahead and edit this. Oops. Let's scoot over. We can go ahead and make this bigger. All right. So we're going to go ahead and put 92 degrees. 4 hours, 4 minutes, pass. And push Control S and save this. So these are just my notes. I think it's just good to have notes so you can kind of keep track of what's going on every time you change something. So you can see I have a different voltage setting up here, blah, blah, blah. So let's talk about these settings real quick. V-Core 1.352, I'm going to show you that in the BIOS here in a sec. Adaptive idle is at 1.344 volts. As you can see here, it's 1.344 to 1.36, I believe. This is going to be different because, yeah, there you go. See how it jumped down. So I just kind of keep a note of where things are at. So I'm gonna actually go ahead and put that 1.36 there. So I just keep a note of where things are at during idle. Oh, whoops. There we go. Sorry, I was watching the camera. Okay, so yeah, just keep a note of what the clock rate is, what the AVX offset is. So I'm going to show you that in a sec. What the V-Core is set, the idle actual voltage here, the actual clock rate, and then this load line. I'm going to show you what that means here in a sec. This setting is awesome. It takes that V-drop or V-droop that I was talking about a second ago. And just a quick note too about this. These aren't exact. I think this only updates in increments of 0.016 volts. So you're going to see the closest setting to you as long as you can round up to that. And this load line setting here, I'll show you in a sec, that is basically a setting that prioritizes the voltage that goes through the CPU under load. And it goes from, I believe, 1 to 7. 1 being pretty much no priority on keeping the voltage proper, and then 7 being like ridiculous. It like basically overvolts it. This setting allowed me to keep the voltage closer to what I actually told it was. So if you look at these other notes here, actual V-Core small FFT, no AVX, that means I literally turn off the AVX instruction set. I'll explain that here in a sec. Usually what I do, I forgot to do this, but what I do is I go ahead and take a snippet. I take a snip of this entire double screen setup. So I go ahead and save that, and then the reason why I do that is I save that in the folder, save as, and it should already be, yeah, it's in my overclocking folder. So I'm going to save this as 4 hour, sorry, it's really hard to type and do this at the same time. 4 hour AVX blend, 4 hour AVX blend and I'm going to call this 4.8 gigahertz because that's the actual clock rate. 4.8 gigahertz pass. And I'm just going to call it pass. So yeah. So these are just photos that I can reference later. It's good to have notes and photos of all of your passing and whatnot. So we're going to close that. So as I was saying, this load line setting prioritizes the actual voltage during the load. So yeah. This notepad here is more so just for me to keep track of things as I change them, because if you have unstable clock rates, you need to understand what's causing the issue. And this test here, this small FFT, is the one I was talking about earlier. That is the hardest test to pass, and it's just the CPU. It doesn't test the RAM. So it'll get really hot really fast. With the no AVX, I turn that off. I'll show you what that means. So if I go to test, or if I go to torture test, and then I click on whatever test I want, there's this setting down here, disable AVX2 and disable AVX. When I turn those off, the CPU does not underclock to those other rates. So you can see how actual vCore small FFT, no AVX, that's going to stay clocked at 5 gigahertz. We're going to go into the BIOS in a sec, like I said. And then I just have the same thing. I keep track of the voltage under load, that's during the test, the maximum temperature, and then I was starting to write which core was the hottest, so I can correlate if there's an issue with thermal paste or something. And then I was writing how much time. So basically I did like a 30-second test on all of them, and then I did like a 2-minute test, and then a 5-minute test, a 10-minute test, 30-minute test. And now I'm running through and doing the 4-hour plus test. And this was the first one that I wanted to do because this is the actual, I think, the closest to the way your system's going to run under heavy load. These tests, the small FFTs, I think are overkill. So I've read forums where other overclockers actually ignore crashes on those if they can get everything else proper. So they know they have to up the voltages for those just to pass the test. So yeah, it's just good to have notes on your actual voltages under test, your maximum temperature, which core was the hottest, how long you were able to pass the test while you're dialing things in. So yeah, here's the actual vCore FFT. AVX offset, that downclocks to 4.8. So, and then load line, 0.01 AC and DC current. This is the upper and lower temperature control limits that I have set. Let's go into BIOS so I can explain these settings. Alright, so we are back into BIOS. I'm going to go ahead and explain all of the settings and what I learned. This video is going to be longer than I thought, but oh well. So I'm going to go here into advanced mode, and we are going to go to the AI Tweaker tab. Let's talk about the settings. So up here is nice because it tells you the calculations. As long as you saved and reset, these will be updated. So target CPU turbo mode frequency is 5 gigahertz or 5000 megahertz. Target CPU at AVX frequency is 4800 megahertz. That's 4.8 gigahertz, and that means whenever an AVX or AVX2 instruction set is detected, the CPU will underclock to this voltage because it runs hotter at the same clock rates. So you try to dial that in to keep your temperatures in check and not crash the CPU, because it's going to require more voltage for these instruction sets. And then we have our target DRAM frequency, which is 3 gigahertz or 3000 megahertz. And then the target cache frequency, this is that uncore that I was talking about. So let's run through the settings. So in the AI overclock tuner, I have XMP enabled, which should automatically detect the maximum clock rate for the RAM, and it'll also set the timings. If you have severe issues, you can go in and set these on your own. So these are the timings. I'm not going to get into that, but these are basically milliseconds for each whatever, and then the voltage. So all that you need to know right now is that we're at 3000 megahertz. B clock frequency, like I said, I'm keeping that at a base 100. You can mess around with that, and most people who do challenges for overclocking, they do end up clocking this higher and then cutting their multiplier in half for the CPU. This I just left to auto. I haven't had any issues with that. This right here is what the AVX core ratio negative offset of 2. This is what takes the base clock rate and drops it down by the multiplier of whatever you set. So 2 would equal 200 megahertz, and that's why you see this difference here. So, and then this other setting here, we have CPU core ratio. All of our cores are clocked to the same rate. If you have issues with one core being hotter than the others and you're having issues with it passing, you could always mess around with that. I didn't really want to do that. I just want to go ahead and stick to all of the cores the same. I'm actually going to link down below the guide that I used for overclocking this CPU. It's a really good guide. Yeah. So I'm leaving this ratio of the B clock to the DRAM. There's, I think, yeah, there's 100 to 133 and 100 to 100. So you could make your DRAM faster than your B clock. Don't think you need to mess with that, at least for what I'm doing. I just left that enabled. Dram Frequency, this should autofill when you turn on XMP. This is the thermal, whatever it stands for. This is basically, so you have, leave it where it's at when you're changing things. TPU1 is a good air cooler, and TPU2 is a good all-in-one or a custom water loop. I don't mess with this. I do not want to load this. This is, I think, higher loads than you need. This setting right here, very, very, very important setting. CPU SVID, disable this item to prevent the CPU from communicating with the external voltage regulator. A setting of disable is recommended for overclocking. The reason why this is enabled is it allows for different C states, which basically means that when the CPU is not being used fully, it can drop the clock rate and also drop the voltage. So I left that on. Most guides tell you to leave it on, but if you're going for extreme overclocking, you'll leave that disabled, and what it means is the clock rate will always stay the same even if the CPU is not being utilized, and the voltage will stay the same. I'm not messing with the timing control. This is, you can go in here and set the different latencies and all that crap. We're not going to mess with that. We're going to go in here to the external blah blah blah. This is what I was talking about. The load line calibration is an amazing setting, and this is what's going to get you a more accurate voltage without load and with load. I have found level 5 to be the most balanced. It keeps it really close to where you're at, and it's not too aggressive, so it does drop a tiny bit, but I'd rather have it drop than raise. 6 and 7, I was finding that it was overvolting and it was getting hotter even at the same voltages, so 5 seems to be the sweet spot. That's the only setting that I changed in here. If you have issues with the RAM being overclocked, you're going to have to go in and change the VCCIO and a couple of other settings down here. We're not going to get into that. That's some more advanced stuff. We're just doing a basic how I got my CPU there. So let's go into the internal CPU management. That is fine leaving on auto, and it's actually fine leaving on enabled. I did experiment with this on my 4.8 gigahertz clock, and I was able to get the CPU to actually properly underclock when it wasn't in load. I'm not too worried about it though. I'm just going to leave it there. This setting is very important actually. My understanding of these two settings here is these are the settings that, how do I say this here? These are the settings, man, this is hard to explain. Trying to think of those are the settings that you're gonna need them on in order to get your voltages proper. It's kind of similar to this here, how this keeps your V drop or V droop, however you want to say it, to a minimum. This setting here basically helps you keep the proper voltage. I'm not doing a good job explaining it, but I did need to have a little bit there. It basically increases the resistance. My understanding at least, it increases the resistance of whatever circuit is supplying current with the AC and DC systems inside the motherboard. Long story short, you need some resistance to keep stable numbers. So that was very important. I did that a long time ago and I haven't messed with it, and it's done me well. This was the main one right here that really took me to the next level, because before I had this set to auto, what was happening is I was going from, let's go down to this here. So these are the Uncore clock rates. I just set those. I left that at auto. You can mess around with the core cache limit. I believe that has to do with voltages. So here we go. If you have this enabled, CPU support, SVID, the voltage regulator turned on, you are allowed to use adaptive mode, which, like I said, allows for C states. Basically, C states allow the CPU to drop the clock rate and also drop the voltages when it's not being utilized 100%. Offset mode basically helps you deal with V drop and whatnot. You can add some to this. I don't really like messing with it. I did mess with it when I had the this setting. There's so many settings. This setting set to auto. It was helping me keep a more consistent clock rate, but everything was higher. So yeah. So right now I have the voltage set at 1.352 and I'm actually very, very stable here. It's a little hotter than I would like. I'm actually going to delid the CPU. That's going to be a whole nother video. I just wanted to get some baseline stability where I'm at, and possibly when I delid it and drop the temperatures, I should be able to drop that just a tiny, tiny bit and get a better stability, lower temperatures, longer longevity of the whatchamacallit. These are also what I was talking about, the VCCIO. You have to mess with these if you have issues with your RAM being overclocked. So let's go in here real quick to the CPU overclocking temperature control. If you noticed my notes, I had these written down. So the upper threshold is at the point at which this whole system kicks in, and the lower threshold is when it goes back to normal. So when the CPU reaches 90 degrees, that's any one single core, and I believe it's for 256 milliseconds or longer, it will detect, hey, we're at 90 degrees, let's go ahead and kick this in. You will see the CPU ratio go down to 4.5 gigahertz, and it's supposed to drop down to this voltage, although I'm having issues with it actually dropping. It looks like it's the same. Maybe it's not reporting properly, but the voltages aren't changing, so I'm not seeing this system work what I believe is the proper way. Offset voltage is the same thing, like I said earlier. You can add a positive or negative. This stays the same. There's two ways to set this, the other menu or here. So it's still set to 2. That's what this does, and they say you're not supposed to mess with this until you get a stable clock, but hey, I wanted some, I just wanted a little bit more safety for when I'm not watching my CPU when I'm running the test. So those are some of the settings here. I'll just run through them really quick again. I have XMP enabled at 3000 megahertz for my DDR4 RAM. My B clock is at 100 megahertz, which is default for this motherboard. The AVX negative ratio is 2. All of my cores are synced at 50 multiplier, which is multiplied by 100 megahertz to get 5000 megahertz or 5.0 gigahertz. The Uncore, well, we'll talk about this. Like I said, Dram Frequency is at 3000 megahertz. The TPU is set to liquid cooling because I have this liquid cooler system. Yeah. SVID is on, which allows for the CPU to drop voltages and whatnot in adaptive mode. We have load line set at level 5, which keeps the V drop to a minimum but does not overvolt it. That is the sweet spot, I believe, on this motherboard and this CPU. I'm not dropping very much under load. Before I had this set to auto, I think I mentioned this, but I'll say it again. Before I had that set to auto, I had my voltages, they had to be up as high as 1.37, and they were dropping way down to 1.2 something under load, which was barely enough to keep the CPU powered. So I just found that this setting here helped me actually get the voltages that I wanted and maintain them so that I'm not overvolting on the lower clock rates and I'm not undervolting on the load clock rate, if that makes sense. So that's what I've learned from all this, and I believe, even though I only passed, let me lift this up, even though I've only passed 4 hours of those tests, Like I said, the small FFT test is gonna crash easier than the blend test. Blend test runs like, I think, about 10 degrees hotter on this system. Even though I've only passed 4 hours, I'm gonna say it's pretty safe to say that this clock is stable, and trust me, I had a lot of issues. I was having a lot of crashing. Once I installed this motherboard, that's actually all I did the first week. I didn't even really play video games except maybe 1 hour once I got somewhat stable. I didn't have them quite right from before, and I mentioned that in my last build video, but I learned a lot in that week, and I learned about that load line calibration, which was a game changer because I was getting tired of having to overvolt to hit the voltages I want under load. You don't want that. You want to tweak with the load line setting of the 0.01, and I believe it's in micro ohms or milliohms. It's some type of resistance setting, whatever. 0.01 was what all the guides were saying. You know, if you know anything about electronics, having a little bit of resistance is actually a good thing for, I guess you could say, stable numbers of voltages and whatnot. That's my understanding. So yeah, I learned a lot. My biggest thing was getting rid of the V-drop or V-droop, and once I did that, I was able to drop those voltages down. And now what you're supposed to do is you're supposed to hit those as low as possible with the highest clock rate. And when I delid the CPU, when the temperatures drop, with lower temperatures you can have higher stability at lower voltage because you're not losing as much electricity to heat. It's pretty crazy. Overclocking the CPU actually makes you think about the physics of electricity and a system losing efficiency due to heat. It's pretty crazy. So stay tuned to TritonTv. We're going to delid this CPU next episode, and then hopefully I have my RAM back from Corsair so I can do an episode on that, and then I'll send out the old motherboard. Thanks for watching. I know it's a lot. If you have any questions on overclocking this CPU, just let me know in the comments, and I will post the guide to how I learned all this in the description. There's multiple guides. Actually, I have a tab on Chrome in my bookmarks that's full of pages that I use for all my research for understanding all this. So hopefully I at least help somebody. All of these policies and systems apply to any CPU. The settings might look a little different in other BIOS, but they're all going to be the same. You're going to apply resistance to the voltage. You're going to apply some type of setting that prioritizes the voltage under load to be closer to the non-load voltage, and that allows you to balance the V-drop or V-droop, however you want to say it. So thanks for watching TritonTv. Make sure to like, comment, subscribe, and make fun of me if you think my hair looks crazy, and if you think I have no clue what I'm talking about. See ya.